Okay, we're going to look at some problems involving applications with both log and exponential functions. So we've got four problems here. The first one, talk about a certain type of bacteria given a favorable growth medium, doubles in population every 6.5 hours. So we're going to have an exponential growth problem, which is a natural growth, so base E. We have 100 bacteria to start. And it doubles every 6.5 hours. So the first thing we want to do, we look at the question. It says, how many bacteria will there be in a day and a half? So we know that we're using y equals n times e to the kt. And even though they don't specify solve for k first, we know that's one of the things that we need to do. So we start with 100. It doubles, so that means that equals 200. K is what we're solving for, and time is 6.5, and we're going to leave it in hours. So we divide both sides by 2. And now we've done everything we can to isolate our variable. So to remove the variable from the exponent, we're going to use the inverse operation. So that's log, and we're going to use natural log because we're in base E. So we have the natural log of 2. We're going to apply the product rule, or power rule rather. So 6.5 t times the natural log of E. The natural log of E is 1. I'm going to divide both sides by 6.5. And then here we are on our calculators. We have the natural log of 2 divided by 6.5. And so K, I put a T there. That really should have been a K, right? Because T was our time. So let's make that adjustment. K was what we're solving for. So K is going to be approximately 0.1066. All right, so now we've got two other questions. How many bacteria will there be in a day and a half? Well, there's 24 hours in a day. That means 12 and a half day. So that means there's 36 hours in a day and a half. So we have y equals 100 is what we're starting with. E, our K is 0.1066, T. So there's our general equation. And so now we're going to input 36 for a day and a half. So y equals 100 e to the 0.1066 times 36. So again, we're going to go back to our calculators. 100 times e raised to the 0.1066 times 36, close our parentheses, and 4,641. We're going to round there. We don't quite get to the next one, and we're going to say there's not a part of a bacteria. So we'll leave it to the closest integer. So now when will there be 10,000? So that means we're solving for the variable t, right? When. It means t, so we set it equal to 10,000, e to the 0.1066 t. So divide both sides by 100. So we get 100 equals e to the 0.1066 t. Again, we're in that same position as we were earlier. We'll take the natural log, apply the power rule. So natural log of e is going to be 1, so 0.1066 t. Divide both sides by the 0.1066. And we're in hours, that's our units. So we have the natural log of 100, close that parentheses, divided by the 0.1066. And we get approximately 43.200 hours. Okay. Let's look at our second problem. It says radioisotopes of different elements have different half-lives, so we know we're going down by half. This particular one, magnesium 27, has a half-life of 9 minutes. So again, we're going to use y equals n times e to the kt. They're asking now for the decay constant. Okay, so that's our k. So remember, it doesn't matter how much we start with, because if I start with 100, half of that is 50, and when we divide by the 100, we end up with half. So here's what I'll do. We're going to just set it equal to 1/2. E And the half-life is 9 minutes, so we have 9K. Take the natural log of both sides, apply our power rule. Natural log of E is 1. Divide both sides by 9. And this should be a negative number, right? Because we're going down, so our K is negative when we're going down. So the natural log of 0.5 divided by 9, sure enough, there's our negative number, negative 0.077. Okay, so our general equation will be y equals n times e to the negative 0.077t, n is how much we start with. So now they said if there's 100 grams to start, when will there be less than 20? Okay, so I'm going to say 20 equals 100 e to the negative 0.077t. And I know that this will give me, when we solve for t, when it actually equals 20. So I know anything beyond that time will be less than 20 because we're going down. Right? Divide by 100. And we end up with 2/10 or 1/5. You can leave it as a decimal or a fraction. Again, we're back to that same spot. Divide both, or take the natural log of both sides. Apply our power rule. Now the natural log of 1/2, that's going to be a negative number, any number between 0 and 1. And then notice we're going to be dividing by a negative number. So that's how we'll get our positive time. And so going again back to our calculators, natural log, I'm going to do 0.2 rather than 1/5, divided by negative 0.077. And we get t is approximately 20.90. I'll round to 2. And remember, our time frame was minutes. So our units here will be minutes. All right, so there's 2 problems. Let's look at 2 more. Here we have a computer that costs $1,500 and it depreciates in value by about 18% per year. Write an equation. So I have y equals our initial amount, 1 because we're depreciating, minus 0.18 raised to the t. So y equals 1,500 times 0.82 to the t. So there's our equation to represent the value after t years. How much will the computer be worth in 6 years? So we're going to substitute 6 for t. So 1,500 times 0.82 to the 6th. Again, all of these computations we're going to do on our calculator. There's 1,500 times 0.82 raised to the 6th. And we see that it is approximately $456.01. And again, because now we're in money, we're only going to go to 2 decimal places. How long will it take before your computer is worth close to $0? So you have to decide, what do I think is close to 0? So I'm going to put 1. That's pretty close to $0, especially considering it started at 1,500. So we're solving for time, right? How long means t. So I'm going to divide by 1,500. Now, just to do it a little differently, instead of doing natural log, I'm going to do the common log. It doesn't matter. I can do log base e or common log. Apply the power rule. I'm going to move this over here, running out of a little bit of room. So t will be the log of 1 over 1,500 divided by the log of 0.82. And let's see. So we have the log of 1 divided by 1,500 divided by the log of 0.82, and you see we get t is 36.85. I'll round to 2. I look at my units, we're in years. So it'll take a little over 36 years to get to $1. And then again, you would justify that as being pretty close to 0. We know it'll never reach 0. Because if we, one thing is that if we were trying to take the log of 0, remember the domain of a log function, the argument has to be greater than 0. But we also know that if we take 0.82, raise it to a power, that never gets to 0. So our original exponential equation never gets to 0 either. Okay, lastly, we're looking at an interest rate problem. We're compounding something quarterly. We start with $100,000, and they're going to first write an equation for how much you'd have after T years. So y equals $100,000. 1 plus, now our interest rate is 0.0101 as a decimal. We're compounding it quarterly, so 4, and we raise that to the 4t. So we have 100,000, and so I do 1 plus 0.0101 divided by 4, and notice we get 1.002525 to the 4t. So there's our equation, and this is how much interest we're going to get every quarter. So it wants to know how much after 10 years. So when t is years, and if I plug in 10, for t, we're going to get 40 because we'd have 40 quarters. But remember, t is in years. So 1.002525 to the 4 times 10. Okay, so I'm going to go back here. 100,000 times 1.002525 raised to the 40th. And so we have then at that point $110,613.58. And then it wants to know when will you have $150,000 in the bank account. So 150 equals 100,000 times 1.002525 to the 4t. Again, remember t is in years. So divide by the 100,000. And we have 1.5 equals 1.002525 to the 4t. I'll go back to using natural log. And then we use our power rule. And this is going to be 4 times the natural log of 1.002525. And so we have natural log of 1.5, close the parentheses, divided by, open parentheses, 4 natural log 1.002525, close our parentheses. And we get t is approximately 40.196 years. All right, so you've seen 4 problems. Hope that helps, and we'll see you soon.